All right, friends, it's time to start talking about the urinary system. So, the urinary system, its major job is to get rid of metabolic waste, specifically nitrogenous waste. Nitrogenous waste is going to be waste that has nitrogen in it. And so, in physiology, you would talk about how when you process amino acids or proteins, so you eat proteins, they get broke down into amino acids. And then you take those amino acids and you flip parts around and take stuff out. So you do things like deamination, where you remove that nitrogen and then you can use it as an energy source, as like a keto acid, or a lot of stuff. And so we're always removing these nitrogen units. And what do you do with it afterwards? Well, you get rid of it because it's waste. Most of those nitrogens could be in the form of ammonia, which is not really good for your body. Ammonia is a really powerful base, and so your body takes that nitrogen in the ammonia and changes it into something else called urea, which is a lot less dangerous. So the principal organs of the urinary system are going to be these things right here, your kidneys, right? These are going to be the parts that are filtering the blood. So it's taking all that waste out right there, and then it transports it down the ureters to the bladder, and then the bladder is just a storage unit until it's the right time to void it, and then you'll void out the urethra. So, pretty simple system on the outside. As we get into it, it gets a little more complicated, of course. So the functions of your kidneys, lots of stuff. The major one is getting rid of this nitrogenous waste, but it also regulates your blood volume. So what is in your urine? Well, a lot of it's water. It's not just pure urea or uric acid. A lot of it's water. What's in your blood? A lot of it is water. And so the kidney can control how much blood pressure you have or how much blood you have by how much water it pulls out and puts into your urine. It also can do the osmolarity by pulling out different salts, or as it pulls out water, it concentrates those salts, regulates acid-base balance and electrolyte balance again. Electrolytes are going to be the salts. It's going to be stuff that is dissolved in fluid, specifically in your blood. It also secretes erythropoietin. So erythropoietin is a hormone that's important in the maturation of red blood cells. And so your kidneys can make more red blood cells, which is really cool. You wouldn't think your kidneys doing that. Regulates your calcium homeostasis and bone metabolism by getting rid of calcium. Clears out hormones and drugs from the blood. That seems pretty straightforward. Detoxifies free radicals. Free radicals are molecules that have unpaired electrons, and they're highly reactive, and they want to bind to stuff, and it can really throw stuff out of whack, and your kidneys can get rid of those. And then in extreme starvation, they can increase blood glucose by using amino acids. Like I said earlier, you can make those keto acids instead, and then use those for energy. So, nitrogenous waste, what's waste? Waste is anything the body doesn't need, right? And so we make a lot of our waste. Sometimes you have food that you eat and parts that you can't use. That's waste. But metabolic waste, this is going to be waste that is made by the body. It's going to be waste that is made through chemical reactions in your body. So, is feces a metabolic waste? Did you make it in your body? If you remember that's a big hollow tube. It's from one end to the other. Technically, it's not in your body. And so feces isn't a metabolic waste product. And so your kidneys don't get rid of feces. That's the system we just talked about, right? Your digestive system. Most of your nitrogenous waste is going to be urea. Again, like I said, it's a byproduct of protein metabolism, moving those amino acids around. Other types would be uric acid and creatine. Uric acid, you might have heard of gout before. That's a buildup of uric acid crystals. Your body has uric acid, not a lot of it. Creatine, creatinine, my bad, happens when you do nucleic acid catabolism. So when you're breaking down DNAs and RNAs, you can make creatinine. So excretion, this is just separating the waste from the rest of the body. So you're excreting it, you're getting it out of your body. We have 4 systems in our body that carry out excretion. One is the urinary, right? One's the digestive, because we just talked about poop. What are the other 2? They're going to be your respiratory system and your integumentary system. When we were talking about skin, we talked about how when you sweat, you get rid of urea. And so your integumentary system can excrete waste. And the respiratory system, what is that? Oh, that one's getting rid of carbon dioxide. That's a waste product. That's something your body doesn't need. And so as you breathe it out, you are excreting carbon dioxide. So what are 4 functions of the kidney besides urine formation? Well, you got erythropoietin, blood pressure, blood volume, acid-base electrolyte balance, calcium, metabolism, and bone health. There's a lot of, but that's at least 4 right there. What are 2 nitrogenous waste? Urea, uric acid, creatinine. Ammonia would be a nitrogenous waste, but it's not one we normally keep in our body. Fish do, which is weird, but fish live in water, and so they just excrete it right away, and they don't have to hold it in their body like we do. Some waste eliminated by other systems. Feces from the digestive, carbon dioxide from the respiratory, and then urea through sweat. Coming on down to our kidneys, this is, again, your major organ of the urinary system. This is the one that is going to be filtering the blood. And so when we look at the kidney, there's a couple things you want to focus on. One is this hilum. If you remember when we talked about the lungs, where those main bronchi come in, that's also called a hilum. Here you can see it on the kidney as this part that kind of bends in. It looks kind of like a beam. So the curvy part of the beam is the hilum. You have your ureter coming out from this renal pelvis. When you look at the kidney and you just cut it in cross-section, there are 2 major parts you can see. There's going to be the inside and the outside. And so the cortex is going to be this part that goes from this renal medulla up to the capsule, the thing that wraps around the entire kidney. And so here is the medulla, everything inside of the cortex. So here's that capsule, that outer covering of the kidney. Coming around, you see that there are invaginations in between these medullary pyramids. These are going to be your renal columns. And then these are going to be the pyramids. At the tips of the pyramids are these little things called papillae. They look like little bitty holes that when you're filtering all this blood, you have these ducts that lead down into the medulla, into those pyramids, and then those ducts join up right here at this calyx, this minor calyx, to empty that urine that is being produced. And then again, there's the cortex. This is going to be the area where you find the nephron, the filtering part of the kidney. And we'll talk about the nephron in a bit. So the pyramids empty into a minor calyx. That minor calyx then joins up with a major calyx. And then those all empty into the renal pelvis. What type of epithelium do you think is in the renal pelvis? It's going to be transitional. You're going to find a lot of transitional epithelium in the urinary system because it needs to stretch, right? And so this renal pelvis can stretch. It can become distended. Where do we find the kidneys? Well, this is the back. This is the spine. You find them right there, right? On either side of that vertebrae. If you look at it, it looks a little bit different. That's because one kidney sits higher than the other. Your left one is going to be higher than your right one. When you look at it, you can see this is the peritoneum right here. So this is that stuff that's covering all the organs inside and lining them. And the kidneys are outside of that. When something is outside of the peritoneum, it's going to be behind it. And so we'll call that retroperitoneal. And so the kidneys are retroperitoneal, outside of that peritoneum. It does have a renal fascia, so this connective tissue that covers it. And it also has an adipose capsule. So it has a layer of fat that also cushions and protects it. And then you finally get down to your renal capsule. And that's where we're going to stop for today, and we will go through the blood flow of the kidney next time because it's a lot.